Hi guys, this is Reena V. George from RVGMATHS Talents. Welcome all of you. We are doing Applied Maths Class 11 CBSE. See, already we have started the lesson Binary Numbers and this is Part 4. Let us continue the class.
If you are struggling with maths, you can join my tuition class. WhatsApp number is given in the description box.
Here, in this lesson, we are doing conversion of decimal numbers to binary numbers. Okay. I think all of you have studied what is binary numbers and what is decimal numbers, etc. Is it? Now let us consider conversion of decimal numbers to binary numbers. Let us consider the decimal number 8. We have to convert this to a binary number. For that, first we are dividing this 8 by 2. Then we will get a quotient and the remainder here is 0. So we are note down the quotient here and the remainder here. Like that we continues. Next we divide this quotient 4 by 2. Then we are getting 2 as the quotient and remainder as 0. Okay. Then next again we are dividing this 2 by 2. Then we are getting 1 as the quotient and remainder is 0. Is it? The same thing is done here. 8 is the dividend here. Or we have to convert 8 to binary number. So 8 is divided by 2. 2 is the divisor. Then 4 is the quotient. Then remainder is 0. So we note down 0 here. Again 4 is divided by 2. Again we are getting 2. Then quotient is 2 here. Then 0 is the remainder. Again it is divided by 2. Then the quotient will be 1. And remainder is 0. So till the quotient becomes 1, we continues this process. Okay. Now we got this as the last quotient 1. And then these are the remainders. So we start from this 1 and goes like this and then goes upwards. Is it? Then write down all these numbers. Starting with this 1, then we are getting 1. Then next remainder 0. Next remainder 0. Next remainder 0. So this is the binary number equivalent to 8. So we can write like this. 8 to the base 10 equal to 1000 to the base 2. So here we have converted this 8 to a decimal number using this procedure. Okay. Let us say another example. See here we have to convert 98 to a binary number. Okay. So we start with 98. 98 is divided by 2. Then we will get 49 as the quotient and 0 as the remainder. Then next again we continues. 49 is divided by 2. Then we will get 24 as quotient and 1 as the remainder. We continues again. 24 is divided by 2. We get 12 as the quotient and 0 as the remainder. Again we are continuing division. 12 is divided by 2. We are getting 6 as the quotient and 0 is the remainder. Again we continues. 6 is divided by 2. We are getting 3 as the quotient and 0 as the remainder. Again we continues. 3 is divided by 2. We are getting 1 as the quotient and 1 as remainder. So we reached till the quotient is 1. Is it? Here we can stop and we can write the binary number like this. Start from here, goes like this, then goes up through all these remainders. Then you can write like this, 1, then 1, then the 0, then the 0, then 0, then again 1, then next 0. Okay, so this is the binary number which is equal to what? 98 to the base of 10. See, we have written here. So here 98 to the base 10 is converted to binary number 11000010 to the base 2. Okay. Then come to the next example, 11. We have to convert this 11 to binary number. Let us do together. I think all of you understood this. First we start with 11. That is the dividend. It is divided by 2. Then we will get 5 as the quotient. And 2 5s are 10. 1 is the remainder. So we noted down the remainder here. Then again we continues with 5. 5 is divided by 2. We are getting 2 as the quotient. 2 2s are 4. 1 is the remainder. So now down this one here. Again we continue division. 2 is divided by 2. We will get 1 as the quotient. And 0 is the remainder. We can stop here. When we reach this 1 as the quotient, then we can stop. Then we can write down the new binary number starting from this 1, then goes rightwards, then goes upwards. So 1 0 1 1. So that is the binary number. So we can write 11 to the base 10 equal to 1011 to the base 2. Are you following? Okay. Then come to the next example. We have to convert this 47 to a binary number. So we divide 47 by 2. Then 2 3s are 6 and 2 2s are 4. Then 46. That means 1 is the remainder. 23 is the quotient and 1 is the remainder. Again we continues division. 23 is divided by 2. We will get 11 as quotient and 1 as the remainder. We continues again. 11 is divided by 2. We will get 5 as the quotient and 1 is the remainder. Again continues. 5 is divided by 2. We will get 2 as the quotient and 1 as the remainder. Then 2 is divided again by 2. We will get 1 as the quotient and 0 as the remainder. Then we can start from here. This 1 then goes upwards. Then 1, 0, 1, then this 1, then this 1, then 1 to the base 2. So that is the new binary number. See, 47 to the base 10 is equivalent to 101111 to the base 2. So this is the new binary number. So this is the binary number equivalent to 47. Then come to the next example. We have to convert 129 to a binary number. So we start with 129. It is divided by 2. We are getting quotient 64 and remainder 1. We continues here. 64 is divided by 2. Then we will get 32 and remainder 0. Again 32 is divided by 2. We are getting 16 and remainder 0. 16 is divided by 2. We are getting 8 as quotient and 0 as the remainder. Again we are continuing. 8 is divided by 2. We are getting 4 as quotient and 0 as the remainder. Then 4 is divided by 2. Then we are getting 2 as the quotient and 0 as the remainder. Then 2 is divided by 2. We are getting 1 as the quotient and 0 is the remainder. So when we get 1 as the quotient, we can stop division. And we can start from here writing binary number. So we can start with this 1, 1, then 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros, then 1. So this is the binary number which is equivalent to 129. So we have converted this 129 to binary number 100000001 to the base 2. Okay, I think all of you understood this, is it? So let us do one more example. We have to convert 1018 to a binary number. You start division with 1018. It is divided by 2. We are getting 2 9s are 18, then 0, then 2 5s are 10. So we are getting 509 as the quotient and 0 as the remainder. Then again continue division. 509 divided by 2. We are getting 254 as quotient and 1 is the remainder. Again 254 is divided by 2. We are getting 127 as quotient and 0 as the remainder. 127 is divided by 2. We are getting 63 as quotient and 1 as the remainder. Then 63 is divided by 2. 2 3s are 6, 2 1s are 2, then 1 is the remainder. So 31 is the quotient. 31 is divided by 2. You will get 215 is 30 and 1 is the remainder. Again 15 is divided by 2. We are getting 7 as quotient and 1 is the remainder. Again it is divided by 2. Then 2 3s are 6. 1 is the remainder. 3 is divided by 2. We are getting 1 as the quotient and 1 is the remainder. So when the quotient reaches 1, we can stop division and we can start writing the binary number from here. So we are getting, we can start with 1, then 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6, then 0, 1, 0. 0, 1, 0. So this is the binary number to the base 2. Okay. So 1018 to the base 10 is converted to a binary number 1111111010 to the base 2. Okay.
Let us see in the next class. If you want free notes or guidebooks, visit my website. All the links are given in the description box. Thank you.